Hey y'all, it's me, Miss B, and today we are talking about condensing and expanding logarithmic expressions. If I'm being honest, I kind of forget what goes in here, so I'm just going to say the product, quotient, and power rule, because I think that's what we're talking about, of logarithms allow many expressions to be simplified or evaluated. Okay, so for starters, if I have this here, it can be solved, and I'll just kind of write out what we're going to have. ln of 4 equals ln of 9 to the x, and we can take that x and bring it to the front. So I have ln of 4 equals x ln of 9, and then x equals ln of 4 over ln of 9, which then is equal to ln of 4 minus 9, like that. So it ends up being ln of negative 5. So don't need to write this down. So don't need to write that down. It's just so that you can kind of see what's to come. Oh no, my letters got cut off here on here. So I'm gonna go ahead and fix these. This should be n, as this should also be n. So if I have log base b, and it doesn't matter what the base is, as long as they are the same, then I can write this as log of m times n. Okay, and so when we're going this way, we're condensing. If I have same base but subtraction, it's going to be log, I forgot my b on this one, log base b of m times n here. And on this one, it's m over n. And then here, if I have a p out front, I can bring it up to the top. So I have log base b of m to the p. So that just hops on up there. And so the definitions of those are there. Okay, so we want to write these expressions as single logarithms. So I have log 5x, log of 3x. So I can, because I have the same base of an invisible 10 right here, I can rewrite this as log, and we don't need to write the 10, of 5x times 3x. So this ends up being log of 15x squared. Okay, and the rule that we used, that property, is we ended up using the, what is it called? The product rule. All right, this one here, I've got the same base of 4, so I'm able to do it. And since I have subtraction, I'm going to use the quotient rule, which says that if I have subtraction, I'm going to take log with the same base, and I'm going to divide those two values. So I have log of 32 divided by 2, which is log base 4 of 16. And we don't really need those parentheses, actually. I'd rather it be without. Okay. This one here, because I have this 4 out front, I can bring it up to this exponent right here. So I have log base 5 of 6 to the 4th. And that's just the power rule. And we'll leave it like that. There's no need to rewrite it any other way. All right, this one we have combined rules. So first let's start with the power rule. So step 1, the power rule. So I'm going to move that log base 2x to the 6th up. So that 6 is coming up here. Bringing that 5 up to the y. Okay, and so because I have the same base here, I can now use the, the product rule. So this becomes log base 2 of x to the 6th, y to the 5th, multiplying those two values together. All right, and so that is our final answer there. I'm going to highlight the answers here. Okay. All right, so with these ones, when we're expanding, you'll notice that I just wrote the side that we already had. So we had the right side here, and I just put the right side right there. So we're just going back the other way. So if I have multiplication and I'm trying to expand, I can write this as log base b of m plus log base b times n. If I have division, it's log base b m minus log base b n. And then that power rule ends up bringing that p to the front. So we have p log base b of m. Am I missing something on those? Nope. Okay, so these again are just the same equations as before. It's just they've been written as, it's the same thing as a equals b is the same thing as b equals a. Okay, so let's write these logarithms as expanded. So I have log of 4x over y. So that's going to be using the quotient rule. And so when we have division, that turns into subtraction. So I have log of 4x minus log of y. And the base is an invisible 10, so we don't need to write it. Let's look at number 2. I've got a exponent, so I'm going to use the power rule. I'm going to move that 3 to the front, so I get 3 log m. Again, no base on that one. Okay, this one here, I've got quite a bit going on. I've got 3 things being multiplied together. I'm going to go ahead and write that out as log base 7 of 49 times x times y. So because of that, I can write this as log base 7 of 49 plus log base 7 of x plus log base 7 of y, since all 3 of those things are being multiplied together. So that is the product rule. Last but not least, this one here, I've got two products again. So first, let's use the quotient rule. So I'm going to turn this into log base 9 of x squared minus log base 9 of 729. You'll notice that I have a little exponent here, so we're going to, on our second round, use the power rule. So that 2 is going to come to the front. So I have 2 log base 9 of x minus log base 9 of 729. All right. So right now we're just focusing on expanding and condensing, but eventually it will help us solve. All right, so here's some things that aren't true. Logarithmic functions are not distributive with addition and subtraction. So I can't do log of 7 plus 3 and make that log of 7 plus log of 3. That's not okay. So I'm going to say those aren't equal. Okay, you can't factor a quotient of logarithms. So if you have log of 7 over 3, that does not equal log of 7 minus log of 3. And finally, you cannot factor a logarithm. So if you have log of oh wait, I didn't write out the right thing here. Oh yeah, I did. This should have been 7 minus 3 is why. So if I had log, let's change numbers to 8 minus 4, then that's not equal to log of 8 minus log of 4. I can't just distribute that through. What I had originally written was the quotient rule. All right, and then finally you can't factor a logarithm. So if I have log of I did the wrong example again. So this goes for plus or minus. I meant to say addition and subtraction, so it doesn't really matter. Okay, so with the quotient of logarithms, if I had log of 6 over log 2, that is not equal to log of 6 over 2. All right, and then as far as factoring goes, if I have log base b of 6, that can't be equal to 3 log base b of 2. You can't just multiply those two things together. So those are 3 common mistakes that people will make. All right, that's all for today.